Hi, are you an electronic engineer, a computer engineer or a science graduate, and interested to learn embedded systems programming, but don't know where to start from? Yes, you have now come to the right place. Hey guys, I am Moesh Bhatkal from ADM Virtual Lab. ADM has been designing and manufacturing embedded tools for the past 4 decades. Our tools, like compilers, simulators, debuggers and logic analyzers, are being used by industry for designing new products. The same embedded tools are also used in education for training purpose. Our tools are currently being used in over 1,000 educational institutes all over the country. Every day the world is becoming more and more digital, connected, and automated. But what makes this transformation possible? It's the use of embedded systems in our daily life. Mobile phones, washing machines, microwave oven, Wi-Fi routers, all are examples of embedded systems. IoT is one of the latest smart home technology trends. This trend will continue to grow, and will have a great impact on the economy, by transforming many enterprises into new digital business. This course is aimed at beginner, who is completely new to Embedded Systems Lab, and also to those, who have already mastered the basic theory, and want to go a little bit deeper, and gain hands-on practical knowledge. This lab course provides a collection of experiments, designed to familiarize students, with various aspects of hardware, and software using Crossware compiler, simulator, and debugger. Interfacing LEDs to the microcontroller is a simple activity, and exposes the fundamental processes of software design, assembly, coding, and testing. 7-segment display is a great way to display decimal numbers, and often found in clocks, household appliances and industrial products. LCD interfacing is an excellent example of using microcontrollers to display visible information, such as time, date, and temperature. Timers and counters play an important role in measuring time intervals, like blinking rate of LED, controlling the sampling rate of the ADCs, counting events, or implement a simple time delay. The purpose of an RTC, or a real-time clock, is to provide precise time and date, for applications requiring time stamping, like digital clock, attendance system or digital camera. An interrupt is a signal, generated by either hardware or software event, requesting immediate attention of the processor. A simple example is when a key is pressed, the external hardware generates an interrupt signal, requesting the processor to increment key press count. An analog to digital converter is used to convert an analog signal such as voltage to a digital form, which can be easily processed by a microcontroller. A voltmeter is simple ADC application. A digital to analog converter is used to convert digital data into an analog output signal. Arbitrary waveform generator uses DAC to generate a periodic user-defined analog waveform. Pulse width modulation is basically a digital, square wave signal, where the duration of the on-time can be adjusted as desired. This way the power delivered to the load can be controlled from a microcontroller. For example, the PWM is commonly used to control the speed of electric motors, the brightness of LED. A UART's main purpose is communication. They are used to transmit and receive digital information as serial data bits. This embedded lab course provides 10 lab experiments, which is scheduled over a 2-week period. Each day focuses on one new practical skill set. All lab training are interactive and led by expert instructors. On Monday, we learn how to set up the Embedded Studio software. We use it to develop and debug our first C program to toggle LED connected to port pins. On Tuesday, we will implement a numeric counter using 7-segment display. While on Wednesday, we learn how to drive LCD. LPC2148 lab requires both hardware and software skills. The skill includes configuring timers on Thursday, on Friday, we learn how to set up real-time clock for timestamp application. In the second week, Mondays, we learn how software should be configured to respond to external interrupt. On Tuesdays we learn how arbitrary waveforms can be generated using digital to analog converter. While on Wednesdays, we convert our embedded application to work like a voltmeter using analog to digital converter. On Thursdays, we control motor speed using pulse width modulation technique. And on Fridays, we combine all our skills and start communicating with PC using serial port. The ultimate goal of the Embedded Lab is to make each one of you capable of designing, building, and testing an embedded system capable of solving complex tasks in just 2 weeks. Master the key skills that every engineer needs now. Time is money. Take charge of your time now. Spend your time wisely. Be successful and confident. Before your labs, preparing for your exams, getting ready for a job interview, adding skills on your resume, preparing for your master's degree abroad, acquire adequate skills for internship, ensuring early promotion in your employment, new opportunities in Internet of Things. Spend your time wisely, invest 1 hour daily, for only 10 days, and save hundreds of hours of self-learning, all this, at an introductory price of, for only, 1,000 rupees. We run 4 batches per day, with a max of 25 students per batch, and the duration is 2 weeks. Training commences on the 1st and 3rd Monday every month. Batch timings are 10 to 11, 12 to 1, 2 to 3 and 4 to 5, as shown in the chart. Registration are accepted 24/7. You need to pay 1,180 rupees and send the intimation to our email address with your preferred batch number and month. If due to operational constraint, we are unable to allot the batch of your choice, then you have the option to select another batch or ask for a full refund. So what are you waiting for? Go ahead and grab this special introductory offer right now.